This instructional video will demonstrate how to use the equilibrium constant value for a given reaction to determine equilibrium concentrations of reactants and products when you're given initial concentrations of reactions. Now, the reactants themselves will stoichiometrically react. So for every 1 mole of the hydrogen and iodine that gets consumed, 2 moles of hydrogen iodide will be produced. This means that for our change, we'll call it x, expect minus 1x, and plus 2x here. Now I'll be suppressing the units going forward for ease of writing, but we are still talking about actual concentrations. And so whatever that change is, this means that at equilibrium we will have 2 minus x molar concentration for our hydrogen, 1 minus x molar for our concentration of iodine, and 2x for our hydrogen iodide. So we can now substitute these dummy values into our equilibrium constant expression, set that equal to the true value of it, and solve the resulting equation. So we will have 54.5 equal to, we take the square of our hydrogen iodide, so 2x squared, and we divide by the concentrations of hydrogen and iodine. So multiplying through and solving this will result in a quadratic equation. And so we expect to get 54.5 x squared minus 163.5 x plus 109 equals 4x squared. Now, the awful algebra involved in doing all of this is being left to you, the viewer, to verify that I am actually getting it right. If we rewrite this, we'll have 50.5 x squared minus 163.5 x plus 109 equals 0. This is quadratic in x, which allows us to use the quadratic formula that x will equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, where we know that a equals 50.5, b equals negative 163.5, and c equals 109. Now again, stepping through everything is worked out here on paper, and I expect you to be able to step through this yourself. And so we get 2 possible values for x. Our 2 solutions, 1.6188 plus or minus 0.6798. With these 2 values, we expect to have 2 possibilities. If we take the upper value, it will require us to have negative concentrations for our hydrogen and our iodine. So that upper value is incorrect because it creates something impossible. And so we use the lower value for x, where x equals 0.939. Now, this result allows us to have positive values for our hydrogen concentration and our iodine concentration, as well as giving us a value for our hydrogen iodide. And doing that substitution, we can actually write out the concentration for all 3 species. 1.061 molar for hydrogen, 0.061 molar for iodine, and the hydrogen iodide 1.878 molar. In order to verify this, we have to substitute these values into this equation. Once we substitute those in and carry out all of the multiplication and division, we'll find that we end up with a value of 54.49. That's sufficiently close to 54.5 that we accept that as verification of retrieving the correct value for the equilibrium constant.